Hello everyone, this is Nepaledi sir from ANR Academy. I am here with you to share about how to find center of the conic. Most of the teachers and students follows a short technique to find center of a conic. You know that is by solving the equations dou s by dou x equal to 0 and dou s by dou y equal to 0, then that gives a point that is known as center of the conic. But most of the teachers and students, they don't know why we are applying partial derivatives with respect to x and y, and what is the reason behind that. They don't know, but blindly they follows solving dou s by dou x equals 0 and dou s by dou y equals 0, that gives center of the conic. Let us discuss the importance of partial derivatives today in depth. We know that general second degree equation in terms of x comma y, that indicates equation of conic, right? And that is s a x square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is the equation that indicates equation of conic section. And applying dou s by dou x and dou s by dou y, then there exists a linear equation in x comma y for both dou s by dou x and dou s by dou y. Put dou s by dou x equal to 0 and dou s by dou y equal to 0. Both gives linear equations. And solving these two linear equations in x comma y, then you will get center of the conic. Blindly we follow this result. But what is the reason behind this? Let us observe. Suppose a conic I am going to select, that is a circle, and for which this is the center, and center is the point of intersection of diameters. These are two lines indicating diameters, and the intersection of diameters is known as center of the circle. And you know the definition of diameter. Diameter is nothing but the path of middle points of parallel cuts, right? But in high school geometry, you studied that the curve which is passing through center, that is known as diameter. But that is not correct definition. Actual definition of diameter is, suppose that there is a circle. The definition is the path of middle points of parallel cuts, that is known as diameter. See, I am going to draw parallel curves first. First one, second, third, fourth, fifth, sixth, seventh, and so on. So many parallel lines exist in this way, but the path of middle points of all these parallel curves, that is known as diameter, remember. Let us mention middle points of these parallel cuts, and for this is the middle point here, and for this line this is middle point, and here it is middle point. So now let us observe the path of middle points. By joining all of these middle points, then you will get a line, right? This is known as diameter of the circle. and such type of diameters, so many exist by drawing different parallel lines and the middle points on that, and by joining them you will get so many diameters, and the point of intersection of those diameters, the point of concurrency, finally gives the center of the circle. Let us see another system of parallel curves I am going to select. Suppose these are parallel curves with same slope. I am going to draw different parallel curves. Now let us join middle points of all these. Here there is a middle point, and here this one also middle point. Now by joining all these middle points you will get another diameter, right? This one. This is also another diameter. In such a way there exist so many lines. The point of concurrency of these lines is known as center, remember. So this is the definition of, actual definition of center of any conic. But there is an exemption, particularly for parabola, center does not exist. Let us discuss next second case, parabola. Suppose this is the parabola. First draw parallel curves. These are parallel curves. Now let us draw middle points of all these parallel curves. Joining them we get a line. This is known as diameter. Okay? In the same way, if I select another family of parallel curves, what happens? Observe. This one parallel to this, there exist so many parallel lines, and now let us mention middle points of all these. Here middle point, and for this one is the middle point, and here, and for this line this is the middle point, and for this one is middle point. Now joining all these middle points we get another line. It is also called as diameter. But here the diameters are parallel, remember, so that there is no point of intersection exists in this case, so that particularly for parabola center does not exist. Next conic. Suppose if you have elliptical shape figure, we know that center is nothing but that is the point of intersection of diameters, and you know the definition of diameter. Diameter is nothing but the path of middle points of parallel curves, remember. I am going to select first pair of parallel lines in this way, and then after that mention middle points and join them, you will get a diameter. Here for this middle point we get here, and for the next line this is the middle point, and to the third line there is a middle point, and next here, and then this is the middle point. Here this one is middle point. Next middle point we get here. Next for the last one here we get. So joining all these, points we get a line. This is known as diameter. Okay. Next, Next parallel curves, next family I am going to select. Suppose that these are parallel curves, and then select the path of middle points. This one is the middle point here, and for which there is a middle point here, here, next, here, and then middle point here, and for which you have middle point here, and for this here, next. In such a way there exist so many points, and joining all these points we get another line, that is also we call it as diameter. The path of middle points of next parallel family also called as diameter, right? Now the point of intersection of diameters, the point of concurrency, this is known as center C, right? So using this concept, now I am going to explain why we are going to apply partial derivatives with respect to x and partial derivative with respect to y to solve the center. See here, I am going to write second degree equation in general, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Assume that any conic other than parabola, suppose I am going to select, suppose that this is indicating an elliptical equation, and now we know that diameter is the path of middle points of parallel curves, right? Now my aim is to find a diameter. Remember, now I am going to find the equation of diameter. Equation of diameter I am going to find. Observe the diameter. Diameter, that is collection of points, and the collection of points indicating a straight line, but those points are middle points of parallel curves, remember. This is middle point of parallel curve. So first I can find, to get equation of diameter, locus point I am going to select alpha comma beta, and first I am going to find curve with given middle point. I am going to find first equation of curve with given middle point. We know that that is denoted by S1 equal to S11. First, using this concept, I am going to find the equation. Curve with given middle point, first I am going to find. That is, this family I am going to find now. You know that the notation for S1 and S11, left hand side S1, in the right hand side you have to write S11. Clearly S11 nothing but the point we have to substitute in the second degree equation in terms of x comma y. Wherever x and y, there you have to write alpha comma beta, and right hand side it gives a constant result. On substituting, right part gives a constant value, but left hand side S1 indicates linear expression in terms of x and y. So S1 I am going to write. First x square you have in the second degree equation, so that you will get xx1. Next, 2hxy, x square, that can be written as xx1 if it is s and s1. If you have y square, then you have to write yy1. If you have 2gx, then you have to write g of x plus x1. And if you have 2fy, then f of y plus y1. When you have 2hxy, do you know how to write s1 in this case? See, take h outside. There are two xy terms. To get linear expression in terms of x and y, there are two xy's, xy plus xy first. To get linear expression, I am going to use 1y and 1x1. If you use in the first term substitution to y and in the second term substitution to x, then only you will get a linear expression, remember. So that x square changes to xx1, 2hxy changes to h of xy1 plus x1y. Next, y square written as y into y1 plus 2gx, that is g of x plus x1. Next, f of y plus y1 plus c become constant, remember. Okay. Now, if you take x common, what happens? Observe. Taking x common, we get here there is x1, ax square, right? Here a, and here it must be b. First term ax square, right? So that multiple a. Third term by square, so that here you have to write b also. Now if you take x common, ax1, and where is x? Here, hy1, and here you have x term, that is g. Okay, x of ax1 plus hy1 plus g. Next, if you take y common, what happens? Observe. Taking y common, you will get here by1. Okay. Next, here hx1. First hx1 and then by1. Next, here y common, so that you will get f inside, and remaining remaining terms, here it is x term, x, y, y, x, remaining gx1 plus fy1 plus c, right? gx1 plus fy1 plus c. This constant, suppose that some k, so minus k equal to 0. And here it looks like a straight line, right? And for which I am going to write slope of the line. You know that slope written as minus of coefficient of x divided by coefficient of y. So minus outside. What is coefficient of x? You have ax1 plus hy1 plus g divided by hx1 plus by1 plus f. Here x1 y1, that is actually alpha comma beta, that is middle point here, right? And we know that the path of middle points is known as diameter. So if you replace x1 y1 with alpha comma beta, you will get here on cross multiplication. What happens? Observe. On cross multiplication, it is ax1 plus hy1 plus g plus m of hx1 plus by1 plus f equal to 0 we get. With the help of curve with given middle point, I got an equation up to here, and for which I am going to write slope, and finally this is the equation This is the relation we got, and here x1 y1 indicates alpha comma beta, and also you can write locus point, that as x comma y also, so that I can write ax plus hy plus z plus m of hx plus by plus f equal to 0, right? So now x comma y, nothing but alpha comma beta. Alpha comma beta, that is middle point of the parallel cut, right? And now, since if suppose the equation in terms of alpha comma beta, that indicates the diameter. Here, this one is the equation. In place of x1 y1, or in place of alpha comma beta, that is variable point x comma y, so that you got this equation. So this indicates the path of middle points, nothing but this is known as diameter equation, right? Yes, it is equation of diameter. It is equation of diameter actually, right? What happens here, observe, first curve with middle points equation, from that S1 equal to S11, I got an equation, right? It indicates an equation, and from this equation, if you write slope minus of coefficient of x by coefficient of y, and on cross multiplication, you will get another result, that is clearly diameter. Why? Because alpha comma beta indicates middle point. When you write in place of alpha comma beta x comma y, that indicates the path of middle points, nothing but that is diameter, remember. And just now you got equation of diameter, this one, that is ax plus hy plus z plus m of hx by plus f equal to 0, right? Let us observe clearly. It looks like line 1 plus lambda into, again this is another line 2 equal to 0. L1 plus lambda into L2 equal to 0 model. So that equation of diameter, this is actually equation of diameter representing family of lines. You know the equation of family of lines. Family of lines whose equation, that is linear combination of intersection of two lines, right? L1 and L2. These are non-parallel lines, ax plus hy plus z and hx plus by plus f here, whose slope is different. So that I am saying there are two lines, these two are intersecting lines, so that equation of diameter represent family of lines. In general, L1 plus lambda into L2 equal to 0 is family of lines. That is, in a simple way, mummy plus lambda into daddy equal to 0. That is the family of equation of family of line. First line mummy, second line daddy. Mummy plus lambda into daddy equal to 0. So equation of diameter that represent family of concurrent lines here, intersecting lines, right? Family of concurrent lines. Actually, this is the equation indicates diameter, right? You got this one, diameter, and this diameter is indicating family of lines, right? Family of lines, and they passes through one common point. Okay. For different values of lambda, there exist different lines in this way. Ax plus hy plus z, hx plus by plus f indicates family of intersecting lines, right? Assume that two intersecting lines. This one, okay, and another line. somewhere here. Actually, this is equation of diameter, and equation of diameter also indicates equation of family of straight lines, concurrent lines. And these family of concurrent lines passing through one fixed point, right? That fixed point is known as center. And here, point of concurrency. And point of concurrency is clearly center of the conic. We got this equation as diameter. So, for different values of m, there exist different diameters, all of them indicating diameters itself, and those diameters passes through one common point that is known as clearly center of the conic. Okay, here m any real number, right? For different real values of m, there exists different diameters in this way, in which these two are two straight lines. Okay, and for different values of m, there exists different lines, and those different lines passes through one common point that is known as center of the conic, remember. And let us observe also, you know that is intersection of these two lines, and that center clearly intersection of mummy plus lambda into daddy. Equation, first equation, ax plus hy plus z equals 0, daddy equation hx plus by plus f equal to 0. Point of concurrency, clearly it indicates different diameters of the conic, and those different diameters passing through one common point, and that common point is clearly intersection of mummy equation and daddy equation, right? And now see, when you have second degree equation, yes, ax square plus 2hxy plus 2 plus 2fy plus c equal to, let us observe what is dou s by dou x. Dou s by dou x, partial differentiation with respect to x, nothing but here you have to treat y as constant. So a constant, x square derivative 2x, next 2h and y, they are constants, x derivative 1, b square constant, its derivative 0, 2gx, its derivative 2g, 2fy and c both are constants, their derivative 0, and hence the result dou s by dou x become, neglect 2, you will get this is equal 0, nothing but also ax plus hy plus z is 0. So this one ax plus hy plus z, that can be written as dou s by dou x, remember. In the same way, if you apply partial differentiation with respect to y, what happens, observe here ax square, while partial differentiating with respect to y, x we have to treat as constant, so ax square derivative 0 and 2hxy derivative become 2hx, and by square its derivative 2by, 2gx c constants, 2fy derivative 2f, that is equal to 0, and neglecting 2 we get hx plus by plus f equal to 0. So that this is actually dou s by dou y equal to 0. This is the reason behind the shortcut solving dou s by dou x equal 0 and dou s by dou y equal 0. So it is very clear that center is point of intersection of these two lines, and also remember these two lines we can easily remember like this. Here observe the equations, what you have, dou s by dou x, in which you have x coefficient ax, next hy plus g equal to 0, and also you have in dou s by dou y. This is hx plus by plus f. Here it looks like all hostel girls, hostel boys, friends. A indicates all, H indicates hostel, G indicates girls, all hostel girls. First two terms with multiple x and y. Next here HBF, you can simply remember hostel boys, friends. H indicates hostel, B indicates boys, F indicates friends. So in this way you can easily remember the results also. Dou s by dou x equal to 0 and dou s by dou y equal to 0. Simply we follow dou s by dou x and dou s by dou y by solving those two equations. Then you will get the center, and also you can remember in a simple way, ax plus hy plus g equal to 0, hx plus by plus f equal to 0. By solving them also we get, both are same, solving them also you will get center, and you can simply remember that all hostel girls, hostel boys, friends, solve center of the conic, remember. So this is about the short technique. I hope you understand everything, the reason behind solving partial derivatives, and for future videos please subscribe my channel and like my